Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 11, Conditions on Measurements that Determine a Triangle. So the Classwork Exploratory Challenge 1 asks, Part A says, can any three side lengths form a triangle? Why or why not? I will leave that to you. Pause the video, write down if you think it's yes or no, and with your explanation, and then when you're done, unpause the video, and we will do an exploration to determine whether or not your hypothesis is valid or invalid. So here we go. B. Draw a triangle according to these instructions. Draw segment AB, length of 10 centimeters in your notebook. So I'm going to get my ruler. I'm going to draw line segment AB, the length of 10. So I start right here at 0, and I go all the way over to 10. Okay, I need to do that again. Went off the edge of my writing pad here. Try it again. Start at 0 and over to 10. Okay, so that just went a little over. I want to be really precise here. So there is 10. So, since it's segment AB, I'm going to label it A, B, and I'm going to tell someone who's looking at this that it is 10 centimeters long. So, there's step 1. Now it says to draw segment BC of length 5 centimeters on one piece of patty paper. Well, patty paper is an old kind of paper that's not used much anymore. It's really like a really thin tracing paper that you can see through. So we've been using sheet protectors. But I'm going to just do this, and I can, since it's electronic, I can manipulate it like the patty paper. So I'm going to draw a segment BC, length 5. So here's a segment of length 5, and right about there. Okay, so there's a segment of length 5, and that is BC, and it is 5 cm. Doesn't look like a 5 cm. Okay, so that's done. Third thing says to do is draw a segment AC of length on a different piece of patty paper. So if we had two pieces of plastic, in other words, and I'll do that in blue, and that has to be 3 centimeters. So I start at 0, and I go over to 3, and there's 3. And I'm going to call that AC, and it's 3 cm. Okay, so now that that's done, it says line up the appropriate endpoints on each piece of patty paper with the matching endpoint on segment AB. So what they mean is, if this were on a piece of paper that you can move around like we did it on plastic, you'd line up the B right here. And then you would take AC and you'd line up the A. Well, I'm going to put them up a little bit, and I'm going to show you that they don't reach. So since C here and C here will never reach, they're too far apart, then I cannot make a triangle. So if I rotate these like so, and move this so that it's right on A like that, and I rotate this one this way, and I move B to there, you can obviously see that they aren't going to reach, and I cannot make a triangle because they're not long enough. 3 plus 5 is less than 10. They'll never reach. Okay, so we've done that. Use your pencil point to hold each patty paper in place and adjust paper to form triangle ABC. So I just did that basically, and there is our result. So now go back up to A, and the answer should be no. Why? Because the two shorter sides have to add up to more than the longest side. Okay, 3 plus 5 is 8. 8 is less than 10. They will not reach. Okay? Part C. What do you notice? Well, I've already explained all this. What must be true about the sum of the lengths AC and BC? AC plus BC has to be greater than AB. Based on your conclusion in part D, what if AC were 3 centimeters as you originally had, but BC equals 10? Could you form a triangle ABC? So now they're saying leave AC 3, but make BC 10. So I'll go back and do that. Make BC 10. So now I'm going to make a line segment that I'm going to use the same color, and I'm going to replace it, and I'm going to make it 10. Okay. There's a 10 centimeter segment, and I'm going to call it BC. Okay, so now when I move that down here and put B right on B right there, and I rotate it like so, and I put that there, is there a place I can rotate this where they will intersect? So that's what we're trying to do with our, if this were patty paper, this is what we're trying to do. So I'm going to, first of all, let me move this other one out of the way. We now made BC 10 instead of 5 and trying to determine if I can make a triangle out of that. Okay, so it takes a little bit of manipulation here with this program, but this is what you would be doing with your sheet protector or patty paper. And as you can see, we can make a triangle with that. Okay, could you form a triangle ABC? And the answer is yes. What must be true about the sum of the lengths of AC and BC if the two segments were to meet and form a triangle? And I've already answered that. The sum has to be greater than the third side. So now exercise 1 says two sides of triangle DEF have side lengths of 5 and 8 centimeters. What are the possible whole number lengths for the remaining sides? So we explored this in class, and for the video I'm just going to explain it, that there is a minimum and there is a maximum length for the third side. So if they give us two side lengths, we take the minimum and the maximum. To find the minimum, we subtract. So we take the longer length, 8, and subtract the shorter and get minus 5, and that is 3. To get the maximum length, we take 5 plus 8, and that is 13. So the angle in between, I'm going to call it angle X, and I don't want to use the angle symbol because of my inequalities. I'm just going to say X has to be less than this sum, but greater than the difference. So the third side, if I'm given two sides, 5 and 8, the third side must be greater than 3, because 3 plus 5 equals 8, and that won't make a triangle. It'll be two lines sitting on top of each other. And if I made the third side 13, well, 5 plus 8 equals 13, so these two would just lay on top of this 13, and it would not form a triangle. So if I pick any value in between, this will work. If I chose 4, 3 plus 4 is 7. 5 plus 7 is greater than 8. That's okay. If I chose 7, 13 minus 7 is 6. That's more than 5. It will reach. So my answer is 3 has to, the angle has to be between, or not the angle, but the segment has to be between 3 and 13 centimeters. So all you do is take the two given sides, subtract for the minimum length, and add for the maximum. Okay, exploratory challenge 2. Which of the following conditions determine a triangle? Follow the instructions to try to draw a triangle ABC. Segment AB has been drawn for you as a starting point in each case. So here's segment AB. Choose measurements of angle A and angle B for triangle ABC so that the sum of the measurements is greater than 180 degrees. Label your diagram, choose your angle measurements. So I'm just going to choose 40 degrees for angle A. You can choose any angle for A, but then you have to add something to it to make more than 180. So let's just start with angle A being 40 degrees. I'm going to use my protractor for this. And when I bring my protractor down, you put the crosshairs of the protractor right on the endpoint A. And make sure your line on your protractor lines right up with your line segment. Angle A is 40 degrees. Now notice there is a 40 over here. And I'm just going to do this one time. So that's 40 degrees there. And there's a 40 right here. So I'm going to put a mark over here. And I'm going to explain what those marks mean. So now if I were to draw an angle over here, there's one angle. Okay, that does look like 40 degrees. But if I choose the other one, and I draw an angle over this way to this 40, well, that's not 40 degrees. That's 40 degrees this side. That would be 40 degrees over here, and actually be 140 here, and that's the 40, 140 that's here. So just make sure you're using the correct outside numbers or inside numbers based on whether they should be obtuse or acute when you are done. Always make sure your diagram makes sense. So now that I've done that, I obviously do not want this one. I want this one over here. So that's the mark I'm going to use. That's 40 degrees. And I'll move my protractor out of the way now, and I get a ruler. And I bring my ruler down, and I put my ruler right on A and rotate it up like so, and I draw a line segment like this. Okay, so there is my angle A, and it's 40 degrees. Okay, I just went a little high there, stay out of the way of the writing. Okay, so now keep in mind what this is asking. The sum of the measures of A and B have to be more than 180. So if I take 180 and subtract 40, that leaves me with 140 degrees. So I need something greater than 140. So how about 145? That's more than 140. 40 plus 145 is 185, which is more than 180. So now I'm going to make an angle that's 145 degrees. So that's obtuse. So I'm going to use the outside over here, and 145 would be right here. So if I make an angle from here that is 145 degrees, okay, it would be right there through that point that I made when I was using the protractor. So this angle is 145 degrees. Now notice that this one's slanted down a little more than this one. So as you go further out into space, these are going to get further apart. In other words, they will never meet, and therefore we will not be able to form a triangle. The answer is no. Okay? And the reason? The sum of the measures actually, let's say the sum of the angles. The sum of the angles in a triangle add up to 180 degrees. 40 plus 145 is greater than 180, so I have no more, I don't have any more degrees to add to these two to get my third angle, so it's impossible. Okay? All right, now number 2 says choose measurements for angle A and B for a triangle ABC so that the measurement of angle A is supplementary. That means the two angles add up to 180 to the measure of angle B. So I'm just going to use the same angle measure of 40 degrees. Okay, and then I'm going to get my protractor. and put this right down on A, right there. Make sure your line on the protractor for 0 degrees lines up with your line segment. 40 degrees is right here, right that mark right there. And now I'm going to draw that. So as you can see, I kind of cheat with this because this this ruler has a protractor built into it, and it tells me the measure of the angle that I have the ruler at. And so when I line that up with A and I draw a segment, it actually went right through that point that I made with the protractor. So that is 40 degrees. Okay, well, what's a supplement of 40? It's 140. 140 plus 40 equals 180. So I need a 140 degree angle. So I will go through this motion again, bringing this down and putting it right on B so that 0 degrees over here is on our segment. We want the outside number for an obtuse. 140 is right here. Move my protractor, bring my ruler over, and draw my line segment. Okay, so what I notice about these is they are parallel lines. So in previous lessons earlier in the year, this is a transversal. These two lines are parallel because the same side interior angles are supplementary. We did that a few months back. So obviously will not form a triangle. The answer is no, and the reason is because 40 plus 140 plus angle C would have to be greater than 180 because 180 plus angle C would be greater than 180 because I can't have angle C being 0 degrees. Okay, so we're going to do it one more time. Let me get my ruler and protractor. Now it says to choose measurements of angle A and angle B for triangle ABC so that the sum of the measurements is less than 180. So I'm going to use that same 40 degree angle just for kicks, and I'm going to move my protractor over here, put it right on A. The 0 line is right on my line segment. 40 is right here, and I'm going to get my ruler, and remember I can do that rotation of 40 degrees, and when I draw my line segment, it's going to go through that segment that I just made. Okay, so there's my segment. And now I want angle B plus angle A to be less than 180. So how about I make it 70 degrees? 70 degrees plus 40 degrees is 110. That is less than 180. So now let's make a 70 degree angle from B. So I put this right on B. My 0 line is right on that line segment. 70 degrees is this one outside because we're working from the right. So there's where my 70 degree will be. And when I line this up for the 70 degree mark, then you see that I was able to make a triangle. So this is angle C. So angle A was 40 degrees. Angle B was 70 degrees. And by the triangle sum theorem, 70 plus 40 is 110. 110 plus 70 is 180. So angle C has to be 70 degrees. Were you able to form a triangle? And the answer is yes. And the reason is because 40 degrees plus 70 degrees plus C degrees equals 180 degrees. 110 degrees plus C degrees equals 180 degrees. And when I subtract both sides, then C equals 70 degrees. It is possible. And there it is. Okay? So which condition must be true regarding angle measurements in order to determine a triangle? The two given angles must add up to less than 180 degrees. Okay, so now we've made the conclusion that two angles in a triangle can't be more than or equal to 180. They have to be less. Now C says measure and label the formed triangle in part A with all three side lengths and the angle measurement for angle C. So measure and label the whole thing. So that's what they're asking us to do. I've already labeled C 70, A 40, and B 70. But now I'm going to measure their lengths. Now your lengths are going to be different in your book because when I project, obviously there's going to be a scale factor of some sort. So I might not get the same exact measurement as you. And when I measure this from 0 over, that looks like 78 millimeters. Or 7.8 centimeters. I'll just use millimeters so I don't have decimals. I'm going to rotate this back up to 40 degrees. Starting at 0 at this point here, that is 75, 6, 7, that looks like 77. That's 80, 79, 78, maybe 78 millimeters. Okay, and then I'm going to rotate this around and measure B to C, and it's 52 millimeters. Okay, so it's all labeled. Angle A is 40, angle B 70, angle C is 70, AB is length 78, AC is length 78, and BC is 52. So I'm going to write that down here. I'm going to write AB equals 78 millimeters. BC equals 52 millimeters. And AC equals 78 millimeters. So there's my my three lengths of sides. Now we've done this part here. Now use a protractor, ruler, and compass to draw a triangle A prime, B prime, C prime with the same angle measurements, but side lengths are half as long. So my A prime, B prime will be half the length of 78. Half of 78 is 39 millimeters. B prime, C prime must be half of 52. Therefore, it's going to be 26 millimeters long. And finally, A prime, C prime is half of AC, and that will also be 39 millimeters. So these are the lengths we're going to use along with the same angle measurements of 40, 70, and 70. So I'm going to write those as well. The measure of angle A equals 70 degrees. No, I'm just kidding. That one was the 40. The measure of angle A equals 40 degrees. Forgot my A. The measure of angle B equals 70 degrees. And the measure of angle C equals 70 degrees. Okay. So there's our three angles we're going to use. And these are our three side lengths we're going to use. I will start by drawing AB. Bring my ruler and my protractor down. And might as well get my compass while I'm at it because it asked for that. So there's my three tools I need in this problem. And I bring my ruler down. And I'm going to make a line segment 39 millimeters long. So there's 39 is one mark less than 40. Right there. Okay. So that is A prime, B prime. And that is length 39 millimeters. Okay, so I'm going to just move this over a little bit, center it like that. Okay, now I want my angle A to still be 40 degrees. So I take my protractor and I put it right there on A. And I make a mark over here. And let me change colors this time to 40 degrees is out here. And I'm just showing you the process, but I can do this with my ruler alone, but I still wanted to show you how to do it with the protractor. And then I'm going to draw a line segment from A to that point that I marked with the protractor, but I might as well draw the segment the correct length this time, and that's what the compass is doing. So let me do it that way. So now I'm making AC, and AC has to be 39 millimeters. So I'm going to draw a line segment that's 39 millimeters long. Okay, so this is 39 millimeters long. And I'm going to label it. Well, I won't label it yet because I'm going to do something here. And what I want to do is I want to use my compass to determine the length of my segment. I'm copying this length, so I'm going to use a compass, because what a compass does is creates a circle with a radius of that distance. So that would be my radius of this circle. And if I move my compass down here onto A prime and make a circle, like so, these two circles are identical with the same diameter or radius, and diameter of course, but this is the same radius. So now, let me erase this one. So what I'm doing now is I'm taking my ruler and I want to make a line segment at 40 degrees like we marked with our protractor, going through that point right there. So what I want to do is draw a segment up and just out beyond that circle. So this segment I made right here, I'll move it right now over to here. That's my AC. This segment here is equal to the length of this from A to the edge of my circle, not counting this piece out here. And I'm leaving that there because I'm going to show you what's going to happen. So now I need to make another segment, and I will make that, I need BC now, so that's the 26 millimeter segment. So I'm going to do that over here, and I'm going to make it blue. So I'm going to put it right here, and I'm going to make it 26. Okay. Oops. Let's not hit that red one. So 26 is right there. Okay. So let me get my ruler out of the way. So this is 26 millimeters. So what I'm going to do now is take my compass, put the point right on its end, rotate this up to 0, bring this in so that I'm matching as close as possible the length of that. It's a little bit short, but if I go out, it's too long. So right there is probably better. And I bring my compass over here, and I put it on that circle right there, or on the end of that AB, I mean, and I make a rotation. Okay. Let's do this again. That doesn't look quite right. Let me move this out a little bit more. And let me remeasure that. That's got to be 26. It's about 26. Okay. So I'm going to bring this over here, right on the end of AB, and make a circle. Okay, that's better. The compass didn't... So you see where these two intersect? Well, that's where those lines are going to end up crossing. And that's why we used a compass. Okay, it's like triangulation. We were finding the location of that, of where they intersect. And then I draw a segment from here down to B. Okay, so there is our triangle. Let me just move these circles out of the way now. Those are just our construction marks. And now I'm going to use the eraser and just clean this up a little bit and erase down to that intersection there. And there we go. There's a little bit hanging over there, but if I erase that, I'll lose my B, so I'll just leave it. And this is C prime. Okay, so we have angles with the same measurement. We used our protractor, and we do know that that is 40 degrees, and this one was 70, and therefore this one was also 70 because of the triangle sum theorem. This piece is 26 millimeters, and the red one was 39 millimeters. Okay. Okay, so now we have this triangle, and so this triangle is an image of the pre-image triangle ABC that is half the size with the same angle measurement. So I'm going to bring this up here and show you. So if I bring this up and put it right in there, that is a triangle that is half the size of the original. All the sides are parallel, all the angles are the same. That's 40, that matches the 70, that matches the 70, and the lengths are half. So if I put that there, this would be the midpoint of AB, this would be the midpoint of AC, and then if I move this over to here, here is the midpoint of BC. Okay, so that's kind of cool right there. So there is an image scaled down by half. So it says, do the three angle measurements of the triangle determine a unique triangle? Why or why not? And we just answered that question. No. We had two triangles back here with the same angle measurements, 40, 40, 70, 70, 70, 70. Obviously, this triangle's half the size. Okay? So no three angle measurements of a triangle do not determine a unique triangle because side lengths can be side lengths make larger triangles or smaller triangles. Make different size triangles. With the same angle measures. Okay? Because side lengths make different size triangles with the same angle measures. Exercise 2 says, which of the following sets of angle measurements determine a triangle? So pause the video, see if you can do this, and when you're done, come back and check. Okay, so now I'm taking into consideration that the two angles have to add up to less than 180, which we confirmed in this lesson. So how I'm going to prove this is I'm going to take the two given angles and add them and say they must be less than 180 degrees. So if I take 30 plus 120, I get 150. 150 is less than 180 degrees, and it's less by 30 degrees. So I know I can make a triangle if I have another 30-degree angle. So the answer to this question is yes, that will make a triangle. So in continuing in this fashion, 125 plus 55 has to be less than 180. 5 plus 5 is 10, carry the 1. 5 plus 2 is 7, plus 1 is 8, and then 1, 8. 180 is not, 180 degrees is not less than 180 degrees. And I'm writing 118. Okay, let's try that again. 180 degrees is not less than 180 degrees. So the answer is no. This one, 105 plus 180 must be less than 180, or 105 plus 80. And I add these, I get 185 degrees. These are degrees. Has to be less than 180 degrees. Okay? This is not true, so I'm going to put a line through it. That is not true, so the answer is no. 90 degrees plus 89 degrees has to be less than 180 degrees. 90 plus 89 is 179 degrees. (179 degrees is less than 180 degrees. So the answer is yes. And since I answered yes, I can actually tell you what the next angle measure has to be. What do I have to add to 179 to get my third angle? Well, it's 1 degree. Very tiny angle, but it is possible. And then finally, 91 degrees plus 89 degrees has to be less than 180 degrees. 9 plus 1 is 10, carry the 1. 8 plus 1 is 9, plus 9 is 18. And unfortunately, that is equal to 180 degrees, therefore not less than, so the answer is no. So it says choose one example from above that does determine a triangle and one that does not. For each, explain why it does or does not determine a triangle using words and a diagram. I will leave that to you. I've explained it as I went over these. That is the end of lesson 11. Review the lesson summary and go do your problem set.